Friday, 5:47 p.m. My manager walked in with that look. The look that means your weekend just evaporated. He said, "We're moving to Aurora PostgreSQL. Legal needs it done before Monday's audit." I had migrated databases before. I thought I knew Oracle. I did not know what was coming. By Sunday night, I had hit 5 separate production-breaking issues, the kind that throw errors on every single request. And I fixed every single one. This video is the full weekend. Every break, every fix, every command. Roundum not existing. Sequences destroying your inserts. Date columns silently losing time data. Stored procedures that had me up until 2 in the morning. If you are planning an Oracle to RDS migration, or you just got handed one with a deadline you did not ask for, stay right here. This is the honest account. Saturday morning, I opened the AWS DMS console and provisioned a replication instance. This is the compute DMS uses to read from Oracle and write to Aurora. It does not store your data, it streams it. I used a DMS that are 5 dots large. Do not try to move 47 gigabytes on AT3.medium. You will run out of memory mid-migration and restart from 0. Once the instance was green, I created 2 endpoints. The source endpoint points at your Oracle host, server name, port 1439, SID, and a username with select any table granted. The target endpoint points at the Aurora PostgreSQL writer, port 5432, database name, username, password. After both endpoints are saved, run test connection on each. Both must return successful before you create a migration task. Skip this, and a misconfigured endpoint will fail your task immediately. You will spend an hour wondering why. Before any data moves, the schema must exist on the target. That is SCT, the AWS Schema Conversion Tool. You download it as a desktop app, connect to your Oracle source, and run an assessment. SCT reads your DDL, every table, view, index, stored procedure, and produces 2 things, an automated conversion of what it can handle safely, and a report flagging everything it cannot. In our case, 336 total objects. 193 converted automatically. 143 flagged as action required. That report is not a failure. It is your migration roadmap. Green applies cleanly. Yellow means partial conversion with warnings. Review each one. Red means SCT could not convert it. That object needs a manual rewrite. Review the full report before applying anything. Fix flagged items first. Apply the converted schema to Aurora. Then, and only then do you start the DMS data task. Schema first. Data second. Always. For Oracle data types cause conversion warnings constantly. Number maps to numeric. Usually fine, but bare number with no precision will generate warnings on every column. Date is the dangerous one. Oracle date stores both date and time. PostgreSQL date stores only the date. The time component is silently dropped during migration with no error thrown. Every Oracle date column must be mapped to timestamp on the target. Miss this, and you lose time data permanently. Varchar2 maps cleanly to Varchar. No surprises there. CLOB becomes text in PostgreSQL, but DMS has 2 LOB handling modes. Limited LOB mode is fast and cap size. Full LOB mode preserves everything but runs roughly 50% slower. If your CLOBs contain large documents, use full LOB mode. Truncated data in production is worse than a slower migration window. Run your data type audit against DBA_tab_columns before migration day, not during it. Once both endpoints pass and your schema is applied to Aurora, you create the DMS migration task. Key parameters: source endpoint ARN, target endpoint ARN, replication instance ARN, migration type, and a table mappings file. Migration type is the first decision. Full load only moves a snapshot at a point in time. Use for a hard cutover with a maintenance window. Full load plus CDC adds change data capture. So DMS continues replicating new transactions after the initial load finishes. Use when you need to minimize downtime. The table mappings file is a JSON config defining include and exclude rules. Specify the source schema name. Use a wildcard to include all tables and exclude any tables you do not need. For our migration, we included the entire app schema and excluded 3 decommissioned archive tables. Start the task, then monitor it with describe table statistics. Watch for non-zero error counts on any table. Those need investigation before you proceed. The DMS full load task finished Saturday around noon. 47 gigabytes, for hours. I connected to Aurora with PSQL and started smoke tests. First query used where roundnum less than or equal to 100. Immediate error, column row number does not exist. Break number 1. Then I ran an insert using our Oracle sequence. Syntax error at or near dot. Oracle sequence.nextval does not exist in PostgreSQL. Break number 2. And DMS does not migrate sequences. It silently ignores them with no warning in the task logs. A report query filtering on timestamps came back with wrong results. Time data had been silently dropped from date columns. Break number 3. A stored procedure call through a function signature error. Break number 4. Then we found column names across all our tables were mismatched due to case sensitivity. Every application query failing with column does not exist. Break number 5. 5 categories of failure in the first 2 hours. Each one fixable. In Oracle, sequences are objects you reference with dot notation. An insert generating a primary key looks like insert into orders values open paren order underscore seek dot nextval comma amount close paren. That syntax does not exist in PostgreSQL. Run it on Aurora, and you get syntax error at or near. In PostgreSQL, nextval is a function call. The equivalent is nextval in parentheses with the sequence name as a quoted string. That works, but it is fragile. You must get the string name exactly right everywhere it appears. The better solution is generated always AS identity. Declare the primary key column as integer generated always AS identity. PostgreSQL handles auto-increment internally. No separate sequence object to manage. No nextval calls in application code. Set start with to continue from wherever your Oracle sequence left off. Query the current value before migration. We converted all 31 sequence usages to identity columns. No Oracle-specific syntax remaining. PL/SQL to PL/PG/SQL is where most manual work lives. The languages look similar, begin and end, variable declarations, loops. That surface similarity makes the differences dangerous. For substitutions come up in almost every procedure. Roundnum becomes limit n. NVL becomes coalesce. Same null substitution logic, different name. Systate becomes now open close paren or current underscore timestamp. Cursor loops using for rec in cursor loop work in both dialects, but test exit when edge cases. The most critical difference, do not put commit inside PostgreSQL functions. In Oracle, a stored procedure can commit autonomously inside its own transaction. In PostgreSQL, a function runs inside the caller's transaction. A commit inside a function body is a runtime error. The caller commits. The function does not. We had 89 procedures to convert. SCT handled roughly half automatically. The rest needed line-by-line review. Budget 1 hour per complex procedure, and you will not be surprised. After every fix we validated before moving on. 3 testing layers. First, row count validation. For every table, compare count on Oracle against count on Aurora. A mismatch means either a migration error or a constraint violation rejected rows. Check the DMS task logs. Second, data sample comparison. For 10 high-value tables, we selected 100 random rows from Oracle, ran the same select on Aurora, and diffed the output. This is how we caught the date to timestamp problem. Row counts matched perfectly, but timestamp values were wrong. Row counts alone would have told us everything was fine. It was not fine. Third, constraint checking. Query the Aurora information schema to verify primary keys, foreign keys, and unique constraints exist and are enabled. DMS migrates data, but does not always carry over all constraint definitions. Also validate date format output explicitly. Write a query that returns a known timestamp and verify both date and time components are present. Sunday morning, data validated, application pointed at Aurora, first production traffic going through. Then performance alerts started. Queries under 100 milliseconds on Oracle were taking 3 to 8 seconds on Aurora. The culprit, missing indexes. DMS migrates table data. It does not reliably migrate every index, particularly function-based indexes and Oracle-specific types with no PostgreSQL equivalent. SCT generates index DDL in the converted schema script, but if any index creation statements failed silently during schema apply, which happens when an index references a column with a type conversion issue, the index is absent with no error surfaced. Run explain analyze on your slowest queries immediately after cutover. Find sequential scans on large tables and create the missing indexes. Also run analyze on every large table right after migration. PostgreSQL needs fresh statistics to generate good query plans. A freshly loaded table has no statistics until you run it. AutoVacuum will eventually gather them, but not fast enough on go live morning. Sunday night, 11:47 p.m. All smoke tests passing. Application live on Aurora. Oracle instance still in warm standby. 52 hours total. Here is what I would do differently. Run the SCT assessment report 2 weeks before migration day, not Friday morning. Every flagged item is real work. Give yourself time. Write your rollback plan before you start. Define the exact steps to repoint back to Oracle. We kept Oracle warm for 48 hours after cutover, and that decision saved us once. Test with a copy of production data, not synthetic data. Synthetic data will not surface LOB column problems or timestamp edge cases. Clone production to a test environment and do a full dry run first. Generate your column rename script from DBA_tab_columns before migration day and test it, not under pressure during the window. Audit every Oracle date column before you start. Remap every result to timestamp. This is silent data loss. No error will warn you. 5 breaks. All fixed. Round them. Replace with fetch first or limit. Sequences. DMS ignores them. Convert to generated always AS identity. Oracle date columns. Always map to timestamp or you lose time data with 0 warning. Stored procedures. Procedure becomes function. Remove every commit from the function body. Run analyze on all large tables immediately after cutover. Keep your Oracle instance warm for at least 48 hours. If this video saved you a weekend of pain, subscribe. I post Oracle to cloud content every week. Next video, Oracle versus PostgreSQL deep comparison. What transfers directly and what will surprise you? See you there.